Hi everyone, my name is Sapin Patel, and today I will be presenting my PHYS2212 Lab 3, which is the magnetic field of a bar magnet. The purpose of this lab is to further explore biotes of art law. It's to view real-life behavior of magnetic dipoles, and to finally see how magnetic fields of a magnetic dipole moment is affected by changing the distance. The physics principles used are the biotes of art law, which we modified for our lab here. You'll see it on the left, which is the B bar equals K R to the N. Then you'll also see the magnetic field due to dipole equation, which is on the right there. Sorry for that voice crack. Finally, we'll use the superposition principle for magnets. That basically means the net magnetic field at an observation location will be the summation of all fields acting upon it. This is the experimental procedure of the lab. On the left, you'll see basically me defining the X is where the magnetometer of my phone should be. We found that by using tape, magnet, and a ruler. On the right, you'll see where the magnet is and where the phone is, more specifically where the magnetometer is in the phone, and you'll see the perpendicular distances. So, in my experiment, this is the data for my experiment. Basically, you can see the farther you go away, the smaller your X component will be. Inversely, the closer you get, the larger your X component will be. Using that data in the averages, we can find N, K, and the dipole moment. Okay, in the red arrow, you'll see basically where I created a variable for mu mag, the magnitude of mu in the skeleton code that was given. On the blue arrow, you'll see the function for the magnetic field. Here, we modified the 4 arrows that represent the magnetic field that's perpendicular to the axis. Here, these are the arrows that are 45 degrees off axis. These are the results of my code. You can see at the top and at the bottom that the B at 45 degrees is at as an X component of 3.44792 e to the negative 4, and Y 1.0338 e to the negative 30. The Z component can be disregarded because it is 0. There are many reasons that my values would not match up to the ideal values. One of which is that I was not doing this lab in a controlled environment one normally would. For example, there are many electronics near me, and it is difficult to use the magnetometer on your phone. There's many real-life variables that affect the experiment. Another reason might be because it is very difficult to find the exact position of the magnetometer at home using tools that we have at home and not tools in a laboratory. Okay, for the first question, what if we hadn't oriented our experiment to compensate for magnetic north and had instead laid out our meter stick at some intermediate angle with respect to Earth's magnetic field? Our results would have changed in the way that our values would have changed because Earth's magnetic field acts in all directions, not just the Y component. So the magnetic dipole would have changed in all 3 directions. Secondly, what if we were to stick 2 identical magnets together? How would we expect our measurements to differ? Basically, the 2 individual magnetic dipoles would just become one bigger it would just act as one magnetic dipole. So the value for magnetic dipole and the value for the electric field would be bigger because it is two magnets, not just it's two magnets acting as one magnetic dipole, while what we have here is one small magnetic dipole compared to the two identical ones together. Okay, my code will be in the link to code will be in description, and thank you for watching.